We end here tonight with a sleeping giant, an ancient supervolcano beneath Yellowstone National Park. It has been snoring for thousands of years, exhaling through the park's famous geysers. As Jamie Yukas reports, recent eruptions have some wondering if the giant is awakening.
Yellowstone's famous park hides a deadly secret. Underneath lies a supervolcano that erupts every 600,000 to 800,000 years, spewing enough ash to cover continents. In 2017, a huge earthquake almost destroyed it, and since then the ground has been shaking with more and more quakes. Why are the locals evacuating the area in the next few days? Let us uncover what the government won't admit about how devastating Yellowstone can truly be. The supervolcano awakening. Yellowstone National Park is more than just a place with geysers, wildlife, and hot springs. Beneath its stunning landscape lies a supervolcano, a massive volcano that could cause a disaster of enormous proportions. To understand the potential danger, imagine a cube 6 miles wide, deep, and high. That's how much lava could come out if the supervolcano erupts. Recently, the U.S. Geological Survey reported over 1,000 minor earthquakes in Yellowstone in just 1 month. These small quakes might be a sign that the supervolcano is waking up. In past eruptions, like those 2.1 million years ago, entire mountain ranges disappeared. The recent seismic activity could be a warning of a future eruption that could cause widespread destruction. The supervolcano at Yellowstone is a caldera volcano. This type of volcano has a huge crater formed when the ground collapses after an eruption. In the early 2000s, scientists used satellite images to see how big the volcano really is. Yellowstone is located in the northwest corner of Wyoming and extends into Montana and Idaho. It is the first national park in the United States and is famous for its wildlife, hot springs, and rugged terrain. Native Americans lived in the area for at least 11,000 years. An organized exploration of the park began in the late 1860s. Yellowstone's unique geology includes hidden fissures and underground forces, making it a fascinating but dangerous place. In 1985, the northern part of the park experienced an earthquake swarm with over 3,000 quakes in just 3 months. This event was caused by the slight sinking of the Yellowstone caldera and raised fears of a larger eruption. As the Earth's crust stretches, tiny cracks form, allowing volcanic fluids to move and create tremors. The rock along these faults can slide or break, causing shock waves that travel through the ground. This process, called earthquake swarms, is common in Yellowstone, with the largest swarm occurring in 1985. Hundreds of earthquakes happen in the park's northwestern region, with the strongest reaching a magnitude of 3.9. These frequent and strong quakes show how unstable Yellowstone's geology is. The Yellowstone system is powered by two forces: a volcanic system that stresses the Earth's crust and a tectonic system that stretches the crust from east to west. This combination of forces causes earthquakes, hydrothermal activity, and volcanic eruptions. Scientists are working to understand what drives Yellowstone's seismic activity. A magnitude 6 earthquake hit the park. It was widely felt, but caused little damage because it was in a remote area. By studying seismic waves from earthquakes, scientists can create images of the magma chamber and caldera, learning more about Yellowstone's geological history. An extensive monitoring system tracks every movement in Yellowstone, providing data to help predict and prepare for potential risks. Since 1973, the Earthquake Hazards Program has recorded nearly 48,000 earthquakes in Yellowstone, with only one reaching magnitude 6. Scientists closely monitor Yellowstone using advanced technology to track its activity. By analyzing seismic waves, they can understand the movements of magma and gases beneath the surface. This helps them predict potential eruptions and understand the park's complex geological system. The monitoring data shows that Yellowstone is still very active, with frequent small earthquakes and changes in the ground surface. This constant activity serves as a reminder that the supervolcano is not dormant and could erupt again in the future. People living near Yellowstone are aware of the risks, and emergency plans are in place to respond to a potential eruption. These plans include evacuation routes and strategies to protect people and property. However, predicting the exact timing and impact of a supervolcano eruption is challenging. Scientists can only estimate the likelihood based on current data and historical patterns. Despite the uncertainties, continuous monitoring of Yellowstone provides valuable information that helps prepare for possible future events. Yellowstone is a place of great beauty and significant geological activity. Its supervolcano has the potential to cause massive destruction, but it also contributes to the park's unique features. The geysers, hot springs, and vibrant landscapes are a result of the volcanic and seismic forces at work beneath the surface. While the risks are real, Yellowstone remains a popular destination for visitors from around the world, who come to marvel at its natural wonders and experience its dynamic environment. Let's explore what lies beneath Yellowstone's surface. Yellowstone's volcanic investigation activity. Increased attention has been given to understanding the park's geothermal features. These features, such as hot springs and geysers, are driven by the heat from the supervolcano below. The geothermal activity not only shapes the landscape, but also supports diverse ecosystems. Bacteria and other microorganisms thrive in the hot waters, creating colorful mats around the springs. These organisms are some of the earliest forms of life on Earth, offering scientists a glimpse into the planet's past. Yellowstone's wildlife is also a key attraction. The park is home to a variety of animals, including grizzly bears, wolves, bison, and elk. These animals roam freely, adding to the park's wild and untamed character. The interaction between the geothermal activity and the wildlife creates a unique environment where nature's power and beauty are on full display. Efforts to preserve Yellowstone's natural features and wildlife are ongoing. Conservation programs aim to protect the park's delicate ecosystems and ensure that future generations can enjoy its wonders. The park's history of exploration and scientific study continues to inspire new research, helping to deepen the understanding of its complex geological and ecological systems. Yellowstone's story is one of both awe and caution. The beauty of the park is undeniable, but the forces beneath it are a constant reminder of the potential for great change. The supervolcano's history of eruptions and the continuous seismic activity highlight the dynamic nature of this iconic American landscape. Through careful monitoring and research, scientists hope to unlock more of Yellowstone's providing insights that could one day help predict and mitigate the effects of its powerful geological forces. Mesa Falls once captured attention with its geological drama, but it was the third and final eruption, called the Lava Creek eruption, that truly transformed Yellowstone. This massive event threw an incredible 240 cubic miles of rock, ash, and volcanic gases into the sky. The sheer scale of this eruption is almost unimaginable. Ash covered cities and countryside alike, causing huge problems for agriculture and infrastructure. The Lava Creek eruption had a lasting impact on the environment, spreading ash across large parts of the continent and changing the world's climate for years. The eruption was so powerful that it created a huge crater known as a caldera, over 30 miles wide and 45 miles long. Today, Yellowstone Lake sits in this caldera. Recent research has found that there are two magma chambers under the caldera. The deeper chamber is 4.5 times larger than the one above it. These chambers are full of molten rock that powers Yellowstone's famous geysers, hot springs, and mud pots. This makes Yellowstone one of the most geologically active places on Earth. The history of Yellowstone's earthquakes goes back to the early 20th century. In recent years, there have been more tremors, which has caused worry about the chance of a major eruption. Although such an event is unlikely, it's important to keep a close watch on the park's geological activity. Scientists use tools like seismometers and GPS to track the movements of magma and gas underground. This helps them understand Yellowstone's geological activity and provide early warnings of possible eruptions. Yellowstone's seismic history is rich and varied. The park sits on top of a network of fault lines connected to a buried supervolcano deep underground. Earthquakes happen as these fault lines move apart and as magma, water, and gas move below the surface. Yellowstone is one of the most seismically active regions in the U.S., with about 1,500 to 2,500 earthquakes each year. Most of these are too small for people to feel, but are detected by the Yellowstone Seismic Network, which has about 50 seismometers. The biggest earthquake recorded in Yellowstone was the 7.3 magnitude Hebgen Lake earthquake on August 17, 1959. Unlike the 1906 San Francisco earthquake, which some mistakenly think was near Yellowstone, the Hebgen Lake quake actually struck right outside the western edge of Yellowstone National Park. It caused widespread damage and triggered massive landslides, resulting in significant loss of life. The quake's impact was felt far and wide, and it changed the landscape. It struck at 11:37 p.m., catching people by surprise. The epicenter was outside the park's western boundary, but its effects were felt throughout Yellowstone and beyond. It triggered landslides, destroyed roads and bridges, and caused the Hebgen Dam to fail, which flooded the area and created a new lake, now known as Quake Lake. The earthquake also affected Yellowstone's geothermal features. Dormant geysers began to erupt, and hot springs and fumaroles became more active. In the aftermath, communities worked together to rebuild and assess the area's vulnerability, leading to changes in building codes and emergency plans. Scientists at the Yellowstone Volcano Observatory and the University of Utah have been working to monitor and reduce risks using advanced technology and real-time data to provide early warnings of volcanic activity. Another significant earthquake happened in October 1983 when a 6.9 magnitude quake hit Idaho's Bora Peak. This quake, while not as strong as the Hebgen Lake quake, still caused a lot of damage in Idaho and neighboring states, including Wyoming and Montana. The shallow quake caused landslides and rockfalls, blocking roads and making travel difficult. The town of Challis, Idaho was hit hard, with many buildings damaged or destroyed and the town's water and electricity systems disrupted. Next, we dive into the science behind Yellowstone's heat, monitoring Yellowstone's magma movements. The 1959 Hebgen Lake earthquake remains an important historical event, remembered for its destruction and the lessons it taught about preparedness. The quake's epicenter was under Hebgen Lake, causing extensive damage to Yellowstone's geothermal systems, including Old Faithful Geyser. In the years following the earthquake, the park saw increased seismic activity, including the 1961 eruption of Steamboat Geyser, the world's tallest geyser. Today, the U.S. Forest Service's Earthquake Lake Visitor Center educates visitors about the 1959 earthquake and its lasting impact. Yellowstone continues to be a hotspot for seismic activity, with hundreds of earthquakes recorded each year. Between June and September 2017, over 2,400 earthquakes occurred, with some reaching magnitudes of up to 4.4. While the chance of a catastrophic eruption is low, scientists and experts closely monitor the situation to keep the public informed and ensure the park remains safe. The story of Yellowstone's geological history is filled with powerful eruptions, significant earthquakes, and ongoing seismic activity. Each event has shaped the park and its surroundings, leaving a lasting impact on the landscape and the people who live and visit there. The Lava Creek eruption, with its massive release of rock, ash, and gases, created the Yellowstone caldera and dramatically altered the environment. The earthquakes, such as the Hebgen Lake quake and the Bora Peak quake, have caused widespread damage and loss of life, reminding us of the power of the Earth's geological forces. Yellowstone's geothermal features, like geysers, hot springs, and fumaroles, are fueled by the molten rock beneath the surface. These features are constantly changing and evolving, influenced by the park's seismic activity. Researchers continue to study these features to understand their origins and behavior better. The deployment of shock detectors and other monitoring equipment helps scientists track the movement of magma and gas, providing valuable data for predicting future activity. The park's history of seismic events highlights the need for preparedness and vigilance. Building codes and emergency plans have been updated in response to past earthquakes, and ongoing monitoring efforts aim to provide early warnings of potential eruptions. Despite the risks, Yellowstone remains a popular destination for visitors, drawn by its unique geological features and the natural beauty of the landscape. Yellowstone's ongoing seismic activity is a reminder of the dynamic nature of the Earth's crust. The park's history is marked by significant events that have shaped its present state, and future activity will continue to influence its landscape and ecosystems. By studying and understanding these geological processes, scientists can help mitigate risks and protect the park for future generations. The story of Yellowstone is one of power and beauty, a testament to the Earth's ability to create and destroy. From massive eruptions to powerful earthquakes, the park has experienced some of the most significant geological events in history. These events have left a lasting mark on the landscape, creating a unique environment that continues to captivate and inspire. Yellowstone's future remains uncertain, with the potential for future eruptions and seismic activity always present. However, ongoing research and monitoring efforts aim to better understand these processes and provide early warnings of potential hazards. By staying informed and prepared, people can appreciate the park's beauty while respecting the power of the Earth's geological forces. The history of Yellowstone is a reminder of the delicate balance between nature's beauty and its potential for destruction. The park's geological features are a testament to the power of the Earth's forces, and ongoing research and monitoring efforts help ensure that people can continue to enjoy and protect this unique landscape. Whether exploring the geysers and hot springs or simply appreciating the natural beauty, visitors to Yellowstone are witnessing a living example of the Earth's dynamic processes. The 1959 earthquake left its mark on Yellowstone, seen in the barren mountainside and the gray, soggy trees around Earthquake Lake. The Earthquake Lake Visitor Center in Cabin Creek Scarp area highlight the park's turbulent seismic history, showing the ongoing geological forces at work. Since 2017, Yellowstone has experienced an increase in seismic activity, with hundreds of small earthquakes recorded each year. These smaller tremors might not get as much attention as the big earthquakes like Hebgen Lake and Bora Peak, but they are a constant reminder of Yellowstone's active nature. Scientists believe these small earthquakes are related to the movement of magma and gas beneath the surface. This activity offers valuable clues about the volcanic system below. Understanding Yellowstone's seismic history is essential. Earthquakes are a natural part of the Earth's behavior and can happen at any time. While many are minor and go unnoticed, some can cause significant damage. Studying these patterns helps scientists predict the next major quake and reduce potential damage to the park and surrounding areas. Now we will examine Yellowstone's powerful shakeups, the silent signals from Yellowstone depths. Yellowstone's earthquakes result from the interaction between the North American tectonic plate and the Yellowstone volcanic system, which includes a supervolcano capable of massive eruptions. Unlike the Lisbon earthquake, which was purely tectonic, Yellowstone's earthquakes are influenced by both tectonic and volcanic forces. The Lisbon earthquake of November 1st, 1755, destroyed much of Lisbon, Portugal, and killed around 60,000 people. With an estimated magnitude of 8.5 to 9, it is the largest known earthquake to hit Europe and Northern Africa, with fires and a tsunami making the devastation even worse. Yellowstone's volcanic system is driven by a mantle plume, a column of hot rock rising from deep within the earth. This plume heats the surrounding rock, causing it to melt and form magma, which rises to the surface and fuels volcanic eruptions. The Yellowstone supervolcano has one of the world's largest calderas, about 30 miles by 45 miles, formed by a huge eruption around 640,000 years ago. Despite its dormancy, the supervolcano is still active, with ongoing seismic activity and ground movement indicating magma beneath the surface. Monitoring Yellowstone's earthquakes involves a network of seismometers that detect and locate earthquakes. These instruments help scientists understand the causes and risks of the earthquakes. Earthquakes in Yellowstone vary widely in frequency and magnitude. The park experiences about 1,500 to 2,500 earthquakes each year, with half occurring in clusters known as seismic swarms. Most are too small to be felt by humans, but they signal ongoing geological activity. Yellowstone's unique landscape includes hot springs, geysers, and fumaroles, all fueled by the volcanic system below. Old Faithful, the most famous geyser, regularly shoots steam and water high into the air. Recent reports of earthquake swarms have sparked concern and speculation about a potential eruption. Yellowstone Lake, North America's largest high-elevation body of water, is a focal point for these fears. Its depth and location within the park's caldera make it a potential trigger for a massive eruption. The lake's unique shape, with southern and southeastern branches resembling fjord-like extensions, and the West Thumb Geyser Basin add to its complexity. The lake's waters are home to various waterfowl species and attract anglers for trout fishing. Regulations enforce a catch-and-release policy to protect native trout from predators like lake trout. An eruption would devastate the surrounding landscape, with molten lava threatening communities and ash clouds darkening skies. This could trigger a volcanic winter, disrupting agriculture and worsening environmental challenges. Rebuilding would be a monumental task. Emergency services would provide aid, and scientists would monitor the volcano's activity to prevent future eruptions. While the likelihood of a catastrophic eruption may seem remote, history shows that these sleeping giants can awaken. Efforts by observatories to monitor Yellowstone's seismic activity continue, but whether these efforts are enough to avert disaster remains uncertain. The rise in small earthquakes since 2017 is a stark reminder of Yellowstone's ongoing geological activity. Each tremor is linked to the movement of magma and gas beneath the surface, offering clues to the volatile system below. The interaction between the North American tectonic plate and the Yellowstone volcanic system is complex. The park's supervolcano is one of the largest in the world, with a caldera about 30 miles by 45 miles, formed by a massive eruption 640,000 years ago. While it's currently dormant, seismic activity and ground deformation suggest magma is still moving beneath the surface. Monitoring this activity is critical. Scientists use a network of seismometers to detect and locate earthquakes, helping them understand the causes and risks. Yellowstone experiences about 1,500 to 2,500 earthquakes each year, with half occurring in seismic swarms. Most are too small to be felt, but they indicate ongoing geological activity. Yellowstone's unique landscape includes hot springs, geysers, and fumaroles, all fueled by the volcanic system below. Old Faithful, the most famous geyser, regularly shoots steam and water high into the air. Recent reports of earthquake swarms have sparked concern about a potential eruption. Yellowstone Lake, North America's largest high-elevation body of water, is a focal point for these fears. Its depth and location within the park's caldera make it a potential trigger for a massive eruption. The lake's unique shape and the West Thumb Geyser Basin add to its complexity. The lake's waters are home to various waterfowl species and attract anglers for trout fishing. Regulations enforce a catch-and-release policy to protect native trout from predators like lake trout. An eruption would devastate the surrounding landscape, with molten lava threatening communities and ash clouds darkening skies. This could trigger a volcanic winter, disrupting agriculture and worsening environmental challenges. Rebuilding after such an event would be a monumental task. Emergency services would provide aid, and scientists would monitor the volcano's activity to prevent future eruptions. The possibility of a catastrophic eruption may seem remote, but history shows that sleeping giants can awaken. Efforts to monitor Yellowstone's seismic activity continue, but the question remains whether these efforts are enough to avert disaster. The Yellowstone Volcano Observatory stood as the main center for watching and studying Yellowstone's volcanic activity. It was a combined effort by the United States Geological Survey, the University of Utah, and the National Park Service. These groups worked together with experts in geophysics, geochemistry, and geology, aiming to give early warnings to the public and rescue workers about any volcanic dangers. They used a mix of seismometers, GPS receivers, and other devices to track small movements in the Earth's crust. These tools help scientists notice signs of volcanic activity and predict the chances of an eruption. The observatory also monitored Yellowstone's many hydrothermal features like geysers, hot springs, and fumaroles. These features often showed signs of volcanic activity beneath the surface. Despite having a reliable monitoring system, scientists always search for ways to improve it. They worked on new technologies like automated aerial vehicles with heat-sensing cameras and artificial intelligence to analyze data in real time. These efforts revealed the system's current weaknesses and the need for better solutions. Moving on, let's see how scientists keep watch over the park. Interpreting Yellowstone's seismic warnings. Maintaining and expanding the monitoring network in Yellowstone's rough and remote terrain pose significant challenges. Scientists had to deal with difficult roads and desert landscapes to set up their observatories, making every step a potential obstacle. The area's harsh weather, extreme temperatures, strong winds, heavy snow, and sudden storms made the task even harder, putting both the equipment and researchers at risk. Winters could bury the stations in snow and ice, while summer storms could damage delicate instruments, leading to frequent and costly repairs. The observatory also faced financial problems. Their work was crucial, but they had limited resources. The high costs of acquiring, setting up, and maintaining equipment meant they had to stretch their budgets thin. This often led to fewer monitoring stations, creating dangerous gaps in their coverage. Important areas were left unmonitored, increasing the risk of missing early signs of volcanic activity. To tackle these issues, scientists looked at new technologies that could handle tough weather and reduce the need for manual maintenance. They aimed to combine data from different sources to make their predictions more accurate. Another focus was on improving communication between scientists, policymakers, and the public. They wanted to use clear and simple language to explain complex scientific ideas and provide timely and accurate information. Scientists hoped to build even more advanced monitoring systems that could detect very small changes in the Yellowstone volcanic system. They also aimed to better understand the processes that cause volcanic activity, which would help them make more accurate predictions and warnings. Some of the new technologies they explored included automated aerial vehicles with heat cameras and artificial intelligence for real-time data analysis. These advancements might help spot patterns and anomalies in the data, but there were still many technical and financial hurdles to overcome. One interesting observation involved the bison in the park. These animals showed unusual behaviors, like restlessness and moving away from certain areas before earthquakes. Some thought this could be a natural warning system for volcanic activity. By studying the bison's movements and behavior, scientists hoped to learn more about how wildlife reacted to geological events. However, turning these observations into a reliable monitoring strategy was still a long shot. The Yellowstone Volcano Observatory was a major effort to monitor and understand the volcanic activity in one of the world's most famous national parks. However, it faced many technical, logistical, and financial challenges. The ongoing work to improve and adapt the monitoring systems showed how complex and difficult this task was. Whether these measures would be effective in the long run remained unclear, leaving much uncertainty about the future of this scientific project. The scientists at the observatory were always looking for better ways to detect volcanic activity. They constantly tested new tools and methods, hoping to find something that worked better than the old systems. Their work often took them to the most remote parts of Yellowstone, where they set up equipment and conducted tests. The rugged landscape and unpredictable weather made their job incredibly difficult, but they persevered because they knew how important their work was. One of the biggest challenges was keeping the equipment running in such harsh conditions. The cold winters and hot summers took a toll on the instruments, and repairs were often needed. This was not only time-consuming, but also expensive. The scientists had to be resourceful, finding ways to fix and maintain their equipment with limited funds. They often relied on donations and grants to keep their work going. Despite these challenges, the scientists were dedicated to their mission. They believed that understanding Yellowstone's volcanic activity could one day save lives. By predicting eruptions and other geological events, they could give people the information they needed to stay safe. This kept them motivated even when the work was tough. The observatory also worked closely with other organizations and experts. They shared their data and findings, hoping to learn from each other and improve their methods. This collaboration was essential, as it allowed them to pool their resources and knowledge. Together, they could tackle problems that would be impossible to solve alone. The observatory played a crucial role in educating the public. They held workshops and lectures, explaining their work and the importance of monitoring volcanic activity. They used simple language and clear examples to help people understand the complex science behind their efforts. This was an important part of their mission, as it helped build support for their work and raised awareness about the potential dangers of volcanic activity. The observatory's work was far from over. The scientists knew there was still much to learn about Yellowstone's volcanic system. They continued to explore new technologies and methods, always looking for better ways to monitor and predict volcanic activity. Their dedication and hard work were a testament to the importance of their mission. Even in the face of numerous challenges, they remained committed to their goal of keeping people safe and improving our understanding of the natural world. As Yellowstones, we must ask, are we truly prepared for its next big eruption? Like, comment, and subscribe to share your thoughts on this pressing issue.